For this lesson, we're going to talk about like terms. So an algebraic expression, something like these two pieces here, which are just variables, coefficients separated by plus or minus signs. Starting with this one at the top, this expression has 1, 2, 3, 4 total terms in it. But when we talk about like terms, we're talking about the terms whose variables are exactly the same. So off to the side here, I'll write like terms. If we examine, starting with 2x, I'll look across the entire expression and see if there's another term that also has an x in it. And this one does. We have a 2x, and we have a 3x. The 2 and the 3 are different, but we'd say that 2x and 3x are like terms. They can be combined together. The other two terms that appear are this 5y and this 0.5y. Those are like terms as well, the 5y and 0.5y. Again, those are similar in that they can be combined. Now, the expressions that we work with can get much more complicated, but it works the exact same way. So if we check out this second piece here, this expression, if we start with this 15xy, what I'm looking for is, are there any other xy's, like exactly x times y? This is xy squared, so that's not a like term. This x cubed has no y's in it, so it isn't. And this is xy squared. Again, that's an extra y than what appears here. So 15xy cannot be combined with anything else. However, if we look at the 4xy, there's this 100xy squared, those two are similar. That is 4xy squared and 100xy squared are like terms. The only one that we haven't looked at is this 27x cubed, but that doesn't compare with anything else. So to recap, in our very first expression, the 2x and the 3x were like terms, and so were the 5y and 0.5y. Those were similar as well. So in example 1, the goal now is, once you have identified like terms, how do they combine? So we can simplify the expression 2x minus 5y plus 3x minus 0.5y. We do that by combining the coefficients in front of the terms. So if we start with this 2x and 3x, 2 plus 3 is 5, so that means we have in total 5 x's. And we'll do the same thing for the y's. There's a negative 5y, you're taking away 0.5 more, that's going to be negative 5.5y. So we took an expression with 4 terms, combined all the like terms together, and wound up with this thing. It's equivalent, it's just simplified. We have x and we have y, those are not like terms, so we cannot simplify this any further. So if we now look at part B, to combine all the like terms here, the 15xy can't be combined with anything, but here we have a negative 4 and a negative 100. We are adding those together to give us a minus 104xy squared. So we can condense those down into one piece. We have this minus 27x cubed left over, which doesn't combine with anything else. And this is it. We have combined all like terms, and we cannot simplify this expression any further. For the last example here, same idea. I want to combine any like terms and potentially use the distributive property to simplify the expressions as well. So if we start with part A, the only difference here is I've just put some fractions in with the question, but we're going to approach it the same way. I want to identify any like terms and then combine them. So we have this negative 2/3 x, and I see that there's also this 1/9 x. I know those two can be combined. So off to the side, I'm going to write down the negative 2/3 and the plus 1/9. And I know whatever the result is, I'm going to put that number in front of the x's. So let's see. Negative 2/3 plus 1/9. That's, if we use 9 as a common denominator, I didn't change the second fraction. I multiplied the first one by 3. That's negative 6 ninths plus 1 ninth. That's a negative 5 ninths. If we combine the x's together, we get negative 5 ninths x. And we just continue until all like terms have been combined. So I see that there's a y squared, and here's another y squared. I'll focus again on just the numbers that appear there. That is a 1/9 plus 3 halves. That's how many y squareds we will have in total. So, all right, I need a common denominator again, and so now 9 and 2 don't have anything in common. I have to take the product of those two numbers. That's going to be 18. And that means I'm multiplying the first fraction by 2. I'm multiplying the second fraction by 9, which gives us 27. In total, that's 29 over 18, and that can't be simplified. If we go back to setting up this problem, this means we have 29/18 y squared. Again, just adding those coefficients. That leaves us with this minus 25xy, but the good news is that's the only xy that appears within this expression, so we just get minus 25xy. So we have completely simplified part A. Now if we check out part B, the difference here is there's going to be some like terms. I see there's, what do we have? We have an A, there's an A here, there's a B here, there's a B there. Somehow like terms will be combined, but we have to use the distributive property first before we can combine any like terms. So let's try this out. In terms of order of operation, I'd have to work in the parentheses first. There are no like terms within the parentheses, so I can't combine anything. That means multiplication is my very next step. So I'm going to take the 5, I'm going to multiply that to my two terms. I'll then take this negative 2 and multiply that to the 3 terms, and let's see what we get. Okay, we have 5a minus 5 times 2b. Okay, then we get minus 2a. That's a plus 2 times 3b. Then we get a minus 2 times 1, and then minus 2. So that was directly using the distributive property. I want to simplify a little bit so we can start multiplying things together. We have 5a, then it's going to be a minus, okay, we have 5 times 2, that's 10b. We have a minus 2a, that's a plus 2 times 3 is 6b. Minus 2 times 1 is just minus 2, and a minus 2 more. If we scan this expression, okay, there's 5a here, and there's this minus 2a, so those are like terms. Here we have a minus 10b and a positive 6b. I can combine those. And at the very end, they're just numbers, but they are like terms. I know I can take minus 2 and subtract 2 more, so let's combine all these parts. Okay, 5a minus 2a means there's a total of 3a left over. Okay, we have a negative 10b and a 6b, so that's got to be a negative number, and 10 minus 6 is 4, so that's 4b. And we have a minus 2, subtracting 2 more gives me a minus 4. So here we use the distributive property, simplified, looked across for any like terms, and combined those to give us our final answer here.